In the last lecture, we described how to install Mario on your PC, and we got our hands on our first input-output table coming from Exciebase project referred to year 2019. In this lesson, we will aggregate the table to build exactly the same one used in the Excel session, and we will implement the same first shock. Coming back to the same script we started in the previous lecture, we now need to simplify our table by aggregating it to consider only 3 regions and 4 industrial commodities. To do so, Mario helps out its users by providing Excel input templates to ease any interaction with the database itself. We will just type word.getAggregationExcel and provide the name of the Excel itself as a unique argument of the function. Such file will be called aggregation. By running this cell and browsing back to our directory, we can see now it contains the new file. By opening it, we can see for each set of information, regions, sectors, consumption categories, and so on, a separate sheet is generated. In each sheet, a list of information contained in each set is provided. Let's look at the regions. We can see the full list of regions considered in the database. Now, if we want to aggregate them into less regions, we just need to assign the name of the new regions in the second column. As for our example, we consider the European Union, Russia, and rest of the world. The same can be done for all the other sets. Once the Excel file is ready, we can save it, come back to Spyder, and read it by running the command word.aggregate aggregation. Now our database should be aggregated according to the criteria passed in the Excel file, and we can check this by running word in the console. Now the database is shaped into 3 regions and 4 sectors. Now that our database is aggregated, we will perform our first exercise. If you remember, it consisted in modeling a simple final demand shock related to the reduction of all houses' temperature by 1 degree in Europe. Again, to implement a shock, Mario provides an Excel template. To obtain it, it is necessary to run the getShockExcel function. This file will be called shock1. Now we can open the file saved in the usual folder and check what's inside. The indices sheet is there just for support, and the user does not need to use it. The main sheet is also there for user support and won't be read back by the script. In the other sheets, the user can implement a shock on any of the matrices named after the sheets themselves. In the case of the first exercise, we remind that it is a final demand shock. Then we go to the Y sheet. The exercise consists of lowering the demand of natural gas coming from Russia to Europe by an absolute amount calculated as 938 million euros, as you can remember by the Excel hands-on session. We can now close this Excel and read it back in the script by using the shockcalc function. We need to specify the name of the file as the path and set y equal to true to indicate that it is a final demand shock. Once the shock is implemented, we can visualize its impact by using Mario plot matrix function. We may want to visualize the impact both on the value added, matrix V, and on emissions, matrix E. The plot matrix function allows us to use the basic functionalities of the well-known Plotly Express package, for which you can find the full documentation online. By running these 2 commands, interactive HTML charts will be generated. As expected, the impact of this temperature reduction in Europe is affecting mostly the natural gas extraction sector in Russia, with a total loss of 768 million euros in terms of value added, which also causes a net reduction of CO2 emissions of 5.4 million tons. All the results have been expressed with respect to the baseline matrix, where no shock is applied.